Good morning, everyone. Uh, Today we will discuss about new unit. That is unit number 17. And in this unit, there are two topics: redox reactions and hydrogen. And both are simple topics, and they are actually fundamental topics in chemistry. So, in the redox reactions, first we study about redox reactions. And in this reaction, means in this topic, redox reaction topic, main we will study oxidation, reduction, oxidation, reduction. And using these terms, we can cover many things in a topic. So when we can say oxidation and reduction, or anything or metal you take, like zinc metal, in DNA cell you studied zinc metal, its property to lose electron to form zinc ion and electron. A species which lose electron and that underwent oxidation. The process is called oxidation. Oxidation is a process in which electron is removed, or loss of electron is said to be oxidation. In other words, we can write yes, in this reaction, O is removed by hydrogen, means hydrogen what used, and conversion of CuO means O is removed. Copper into, here actually copper plus 2 state and here 0 state. Here 0 state, 2 plus state. Then plus 2 to 0. 0 to plus 2. Means anyway, a hydrogen added or O is removed, then it is called reduction. And so in oxidation, don't write this one, but actually the process is called reduction. Okay. Take metal like sodium burns in air to form Na2O, Na2O2, etc. Sodium oxide, sodium peroxide. But O is added, O reacted with metal. Means metal undergoes oxidation, or Na0 into plus 1. Increase in oxidation number. Anyway, if O is added, then electron removed or even hydrogen removed, CS3, CS2, CHO or CS2OH, CS3, CS2, CHO. Here H is removed, removal of hydrogen, addition of oxygen, then removal of electron. In all the cases, we can say oxidation. When maximum reactions, we will consider what loss of electron and gain of electron. Loss of, even in electrochemistry, we studied only two types of reaction: oxidation reduction involving electron loss and electron gain. Electron loss and gain. Then in reduction process, copper plus 2 electron gives copper. Here electron added and copper ion into copper. Electron, addition of electron, reduction. Next, zinc plus copper plus 2 gives zinc ion plus copper. Now only proved copper undergo reduction and zinc undergo oxidation. But see how it undergoes. Zinc to zinc ion, copper ion to copper, increase in oxidation number or electron removed from this one, and it is called oxidation. Copper plus 2 to copper, electron added, reduction. A species which undergoes oxidation, it is called reducing agent. Or reductant. Species undergoing oxidation, that is called reducing agent are reductant. Means it reduces copper ion to copper. Means reducing agents are reductants, they reduce others, but itself undergo oxidation. See here, itself undergo oxidation, but for others they reduce. Hence they are called reductants. Zinc can act as reducing agent for copper plus 2 to copper, because zinc donate electron and copper gain electron. And after when it donate electron is said to be oxidizing agent or oxidant. Sorry, donate electron is said to be reducing agent because it undergo oxidation. So no confusion. A species undergoing oxidation is called reducing agent or reductant. Species undergoing reduction, that is called oxidizing agent. Example, KMnO4 into Mn plus 2. KMnO4 into Mn plus 2. In KMnO4 plus 7 in Mn and Mn plus 2, plus 7 to plus 2 decrease in oxidation number, that is called reduction. Means MnO4 undergo reduction, therefore potassium permanganate is said to be oxidizing agent. Okay. Like this we can study oxidant, reductant, oxidizing agent, reducing agent, and what is meant by oxidation, reduction. Then how to find oxidation number? Rules we will study. Oxidation number. Say example, potassium permanganate. Yes, we don't know oxidation number of Mn, and let K value, so it is Mn equal to let's say plus 1, 4 into minus 2 equal to 0. This is the formula or method to find the oxidation number of any element in a molecule. And X equal to plus 7, minus 8 plus 1 equal to plus 7. Like this you can calculate the oxidation number, but this oxidation number is nothing but residual charge or apparent charge. Residual charge or apparent charge possessed by an atom of the element in a molecule or ion. Element in a molecule or ion, that is said to be oxidation number. Let's see what are the rules how to find oxidation number. Okay, one of the rules is this one. Okay, I will tell you different points regarding oxidation number calculation. Okay. Oxidation number of any element in free state equal to 0. Free state, Fe, free state, Na, free state, O2, H2, O3, N2, Cl2. So these are elements, molecules, but they are having only one type of atoms. And if they are like this, then their oxidation number found to be 0. Oxidation number of ozone 0, chlorine 0, but sodium in sodium chloride, oxidation number of sodium in sodium chloride equal to plus 1. Oxidation number of O2 means oxygen in sodium oxide equal to minus 2, like that. But in compounds they have some values, maybe positive or negative. This is the first point. Second, oxidation number of alkali metal means group 1 elements, lithium, sodium, potassium, rubidium, cesium, etc. And these have plus 1 oxidation number. And group 2 elements, a second element, there is a lithium, then beryllium, magnesium, calcium, strontium, barium, and radium. And these are group number 2 elements, and all these have same oxidation number plus 2. Group 1 plus 1, group 2 plus 2. Then in the case of halogens, common oxidation number, there is minus 1, but they have tendency to lose electron also, then they have positive oxidation number, except F. Fluorine, it can have only minus 1 oxidation number, but chlorine, bromine, iodine, we can indicate by positive oxidation numbers also. And the noble gases, last group element, group number 18, and all those have oxidation number equal to 0, because electron cannot be added or removed from those what noble gases, except what Xe, xenon compounds. You studied some xenon compounds and they can lose electron. Then oxidation number of hydrogen, oxygen. Oxygen number of H in many compounds found to be +1. In peroxide -1. Free state 0. In methane, oxygen number of H +1. Ethyl alcohol H +1. NH3 H +1. H2O H +1. Hydrogen peroxide means in peroxides H value -1. And free state hydrogen gas, then oxygen number 0. But for oxygen in compounds -2. In compounds -2. Like metal oxides, aluminum oxide, zinc oxide, organic compounds, carboxylic acids, RCOH, alcohol, ROH. To take organic, inorganic, any compound, yes, they contain in maximum cases -2. But there are some exceptions. In free state there is 0, O2 0, -2, +1, +2, +1 in O2F2, +1, +2 in F2O or OF2. Okay, and in superoxides, for example, KO2 you take. This is a 2x plus 1 minus 1/2. KO2 2x plus 1 equal to 0 minus 1/2. Yes, oxidation number of O2 means oxygen may be -2 plus 1 plus 2 minus 1/2 and 0 means total 5. But oxidation number may be fraction, negative, positive, 0. But valency always whole number. Valency of oxygen 2 minus. Valency of nitrogen 3 minus. But oxidation number of nitrogen we can write +1, +2, +3, +4, +5, even in minus 0, etc. But valency of N always 3 minus. O 2 minus. Then S 2 minus. Halogens 1 minus. Like this we can write valency and oxidation numbers. H and O overs. Then hydrogen in interstitial compounds like nickel, palladium, then platinum. In that hydrogen gas is filled in cavities. But there also hydrogen oxidation number found to be 0. Then sum of the oxidation number of all the atoms of the different element in a molecule, neutral molecule, equal to 0 or equal to charge. If it is MnO4 -1, write equal to -1, and CrO4 2 minus, write equal to 2 minus. Like this, you can calculate oxidation number of elements or atoms of the different elements in a molecule. In case of paradox, it is important. Paradox. Example, you take Pb3O4, Fe3O4, C3O2, Br3O8. If you get fractional oxidation number like 4/3, 16/3, means if it is fractional oxidation number, then it is called paradox. But actually, if it is literally 16/3, so whether electron can be removed as 16/3, 16/3 electrons are removed, or 16/3 electrons are added, yes, fractional electrons cannot be removed or added. Therefore, this is the average of total atoms of the same element in a molecule. That is the average. That is actually called as paradox. Now, if you write structure of the substance, then you can know how it is. It is actually PbO plus PbO2 Pb3O4. Then in this case, oxidation number of Pb plus 2, Pb plus 4. This individual we can mention, and even in Fe3O4, FeO, Fe2O3. Then these are called mixed oxides. Mixed oxides. But Fe3O4, see here. For this one, 3x plus 4 into minus 2 equal to 0. 4 into 2 minus 8. X equal to 8 by 3. 8 by 3. Next. Last one. 3x plus 8 into minus 2 equal to 0. X equal to 16 by 3. Here. X equal to 3 to the 6 minus 6. C3O2. 2 to the 4 by 3. 3x equal to 4 by 3. Yes. And here also same. FeO 3x 4 to the 8 by 3. Same. Yes, what are these? These comes under paradox. Then means if you get fractional oxidation number, yes, there comes under paradox. But if you write structures, see actual oxidation number. Here I told oxidation number for O Fe plus 2 plus 3 because here 3 plus 3. In Fe3O4, oxidation number of Fe will be, but don't take 8 by 3. This is called average oxidation number of what? 3 Fe. Then for individual Fe, here for FeO, first oxidation number is plus 2, second one plus 3. Similarly, PbO, plumbous oxide or plumbic oxide, plumbous plus 2, plumbic plus 4, like this. And in case of C3, see here. Carbon suboxide, it is said to be carbon suboxide. Now see here, O minus 2, O minus 2. Therefore, C must be plus 2. Plus 2. And carbon links with carbon, carbon with carbon. Therefore, it should be 0. Plus 2, 0, plus 2. The oxidation number of carbon in what? Carbon suboxide is, you may get this one 4 by 3 answer, but one of the answer is plus 2, 0, plus 2. But you have to take this one plus 2, 0, plus 2. But don't write answer what 4 by 3. If they give question, average oxidation number of carbon in carbon suboxide is average, then you write this one. Okay, same type, bromine. 3Br, like this you write 3Br, and O8 for each link oxygens, because you know valency of Br, so this maximum oxidation number is 7. Valence electron of halogen equal to 7. Therefore, 7 bonds you can write. Now, in between is, we cannot write one more bond. Next, all these three have same oxidation number. Therefore, minus 2, minus 2, minus 2, minus 6, and this should be plus 6. Minus 2, minus 2, minus 2, plus minus 6, plus 6. Minus 2, minus 2, minus 4, plus 4. Therefore, plus 6, plus 4, plus 6. Oxidation number of bromine in tribromo octoxide will be, yes, plus 6, plus 4, plus 6. Then if they ask average of or average oxidation number of Br, then write this one 16 by 3. Because 3 Br and 16 here 1, 2, 3, 4, 5, 6, 7, 8. 8 into 2, 16. 16 by 3 fractional. So this part important, and others are very simple. Oxidation number of N in ammonia, oxidation number of N in HNO3, etc. Those we can calculate very easily. Even in coordination compounds, you studied how to find oxidation number of atoms and elements in a molecule. Then how to balance the equations. There is the next part in the topic, balance equation, and about linear cell reactions are there, and those are covered in electrochemistry. Now, how to balance the equations? There is by oxidation number method or ion electron method. Take example, MnO4 minus plus oxalate ion C2O4 minus in acid medium gives. Usually they give equations and they are asking X, Y, Z, number of moles. Then say how to balance it or how to write products. Possibility in acidic medium, permanganate ion changed into Mn plus 2. It is in acidic medium. In alkaline medium or neutral medium, permanganate ion changed into MnO2. Remember, it is most important. In alkaline medium or neutral medium, permanganate ion changed into MnO2. And acid medium, this ion changed into Mn plus 2. And C2O4 becomes CO2. And H and O combined to give S2 over. And find X, Y, A, B, number of moles. And in the theory you studied about one page regarding the balancing the equation by oxidation number method or what? Ion electron method. Now before that, first better you write the oxidation number of element on the species. Mn, see here, 4 into minus 2, minus 8 plus x equal to minus 1. Therefore, plus 7. This one. 4 into minus 2, minus 8. 2x minus 8 equal to minus 2. Then minus 6, minus 8 plus 2. Sorry, plus 8 minus 2 plus 6. Plus 6 by 2. Therefore, means oxidation number of one element, there is carbon. Carbon atom I calculated plus 3. For 1C plus 3. For 2C plus 6. Plus 3 plus 3. Next, here carbon 2 2s are 4 plus 4. And S plus, don't worry. Last at the end you have to compare. Mn to Mn, carbon to carbon. Plus 7 to plus 2, electron added, reduction. Five electron transfer, because 7 to 2, 5 electron transfer. And plus 3 to plus 1, 1 electron removed. 1 electron removed. Okay. But here 2 number, here 1. Then balance it. When you write 2 here, write here 2. So I have completed this one in one line only, not writing 3-4 steps. You also follow this method. It is an easy method to solve what balance in the redox reactions. Then here 5, here 2. Now interchange this 5 number given to carbon, 2 for Mn. Then finally we can write, see here, 2 MnO4, 2 Mn. Next, C2 already over, but for C2, which value? Carbon value 2 multiplied for Mn. Then Mn value 5 multiplied for C. Therefore here 5, 5. 5 into 2, 10. But in the beginning only I written 2, 2. Means C2 balanced. But at the end, this number multiplied and they will become 10. Over MnC balanced. Finally, balance the oxygens. Okay. Now, but whatever charges are there, but I written this one oxidation number. This is the charge, oxidation number, and also charge. This is the charge. Don't confuse. These are oxidation numbers. Oxidation number and charge. Here oxidation number. Okay. Now number of hydrogens. 5 4s are 20. 2 4s are 8. 28 O. 10 into 2, 20. Plus 8 is 2. 16 H plus. Over. And last step, most important, last step, you have to check by balancing the charges. Now I told, don't consider oxidation numbers for balancing the charges. 2 into minus 1, minus 2, 5 into minus 2, minus 10, plus 16, equal to, plus 4, minus 12, plus 16, plus 4, LHS. RHS, don't consider this plus 4, only charge on the metal ion. 2 into plus 2 equal to plus 4. Means whatever I told method, that is correct, because charges equal, number of atoms equal, everything is known. Now this method you follow to solve different questions, whatever given in the question bank. It may be oxidation number method or ion electron method. If the electron method, mentioned there, electrons added, electron removed, etc. Okay. So this is in case of what balancing. Then disproportionation reactions. When the reaction is said to be disproportionation. Take best example, chlorine and alkaline medium gives Cl ion and OCl minus. Example, chlorine plus sodium hydroxide gives sodium chloride and sodium hypochlorite. Sodium hypochlorite. Now, mention oxidation number of element which undergoes change. Therefore, 0 chlorine, minus 1 OCl minus 1, oxidation number of Cl. This is OCl minus 1, for oxidation number of Cl is X plus of minus 2 equal to minus 1, X equal to plus 1. Yes. 0 to minus 1, 0 to plus 1, 0 to, now consider this is 0, 0 to minus part, 0 to plus part, 0 minus 1 decrease, 0 plus 1 increase, 0 to minus 1 decrease, therefore reduction, 0 to plus 1 increase, oxidation. So same element or species which undergoes both the reaction, there is a oxidation as well as a reduction, then they said to be redox reaction. But one species undergoes two types of reactions, oxidation and reduction, then it is called disproportionation. It is said to be disproportionation reaction. So just after a few minutes, I'll tell you how to solve the questions using the question bank.